Today we're going to talk about solving multi-step inequalities. So again, similar to when we solved the equations, we're still going to use our SAD-MEG, which is the opposite of GEMDAS, to solve our equations. We just have to be on the lookout for that multiplying or dividing by a negative number, which tells us to reverse the symbol. So looking through a couple of examples. So this very first one, we see division, we see addition, so that would tell us subtract the 7s first. We would then bring down the y over -6 is less than 2. We then multiply by the -6, and then notice by multiplying by the negative, we are also going to reverse the symbol. So the inequality now becomes not less than, but a greater than. So y is greater than -12. So the open circle, and then all numbers that are greater than -12, we show that with the bold arrow going to the right. On our second example, we would then have plus 4 on both sides to get the 2v is greater than or equal to 12 divided by 2. No reversing of symbols here. We don't have the v on the right hand side. We also don't have any division or multiplication by a negative. So we would then have v is greater than the or equal to the 6. So we put the 6 with the 2, 7, and 5 around it, with the bold arrow going to the right. So then I look at this next example where I'm solving with variables on both sides. Again, we're just following just like this was an equal sign down the middle. So we would be first bringing the variables to the same side. Again, I don't have to bring them to the left. In this case, we decided to bring these over here to make 4x minus 5 is less than 11. We're adding 5 to both sides, dividing by 4, and we get this. This doesn't ask us to draw the graph, so that's why I didn't draw the graph, but you would have a number line with an open circle at the 4 going to the left. On my last two examples here, I see the first variables on both sides, but we have a little bit of work to do, so we did our distributive property to get 8b plus the 12. We decided to subtract 8b's, and notice how they become zeros and both cancel out. So just like when we had these special solutions with equations, we just keep bringing down the numbers. So the -3, the greater than, the 12, this is not a true statement. If it's not a true statement, we would say there's no solution. On this example, we did our distributive property. We subtracted the 10 w's from both sides, which caused the w's to disappear. We get -2 is less than or equal to 7. Now it's not equal to each other for sure, but the -2 is less than 7, which is a true statement, which means our solution is in infinitely many solutions. So hopefully this is good. Hopefully we are good with all the inequalities of the 1 steps, how to show them as graphings, the 2 steps, how to make sure that we are paying attention to the dividing or multiplying by a negative number. And if you have any kind of questions, please let me know, and we can talk about that in class.